How does electron flow differ from conventional current in electricity? Imagine a tiny world inside your wires where particles are constantly on the move. This invisible dance powers everything from your phone to your refrigerator. But have you ever wondered which way the electricity really flows? Let's uncover the truth behind how electrons and current move in circuits. In a metal wire connected to a battery or power source, electrons are negatively charged particles. They actually drift from the negative terminal, which has a lower electric potential, toward the positive terminal, which has a higher electric potential. This movement is what we call electron flow. Think of it like tiny particles swimming from the negative side to the positive side inside the wire. Even though they move slowly, their collective movement creates an electric current that powers your devices. Now, here's where it gets interesting. Historically, scientists thought of current as flowing from the positive terminal to the negative terminal. This idea is called conventional current. It was established before electrons were discovered and became a standard way to analyze circuits. So, even though electrons move from negative to positive, conventional current is considered to flow from positive to negative. It's like describing a river's flow as going downstream, even if the water actually moves upstream in some parts. This difference might seem confusing, but it's mainly a matter of perspective. Electron flow shows the real physical movement of negatively charged particles. Conventional current is a simplified idea that makes circuit diagrams and calculations easier. Engineers and electricians often use conventional current because it matches the symbols and conventions in circuit diagrams. Even though electrons move from negative to positive, the electrical effect spreads through the wire almost instantly. This quick propagation allows devices to respond immediately when you turn on a switch. So, whether you think of current as moving from positive to negative or electrons from negative to positive, both models help us understand how electricity powers our world. In everyday life, this distinction doesn't change how your light bulb turns on or how your phone charges. It's just a different way of describing the same process. The key is knowing that electrons physically move in one direction, but for simplicity and historical reasons, we often say current flows the opposite way. This understanding helps us see the unseen movement that keeps our modern technology running smoothly.